In this video, we'll be going over the memorization approach of interleaving strings. Let's go over the thought process. The recursive approach is inefficient due to overlapping recursive calls. We can avoid overlapping recursive calls using memorization. Now, what do we need to cache? In each of the recursive call, we are checking if we can interleave. So we can say can interleave the two strings at the current indices I and j. This means we can cache I and j with can interleave. Let's go over the pseudocode. So let's validate the input parameter first. If the sum of lengths of S1 and S2 is not equal to the length of S3, then we can just return false, because we cannot interleave the two strings to create S3. Now we're going to create a 2D matrix, Memo, to cache previously calculated results. So in this case, the rows indicates I, the columns indicates j, and the values indicate can leave. Can interleave. Now we can implement the top-down memorization approach, and then we're going to pass in our Memo, our cache. Then what's the base case? We didn't change the base case. Is if I and j are both out of bound, this means we have successfully interleaved the strings, then we can return true. Then if Memo I and j is not equal to null, this means we have already calculated the results for the current ij, so we can return Memo ij. Then each of the recursive calls, if I is not out of bound and the current index at I inside S1 is equal to the character at index I plus j inside S3, this means we can check if we can interleave the strings by moving I forward. Then if the recursive call is equal to true, we want to cache this first. So if the recursive call is true, put true at Memo ij, then you can return true. Same case here. So if j is not out of bound and the current index at j inside S2 is equal to the character at index I plus j inside S3, we can recursively check if we can interleave the strings by moving j forward. And then if the recursive call is true, we can put true. We want to cache the result too. We want to cache the result, put true, and then we can return true. Else, if we have failed to interleave the strings, then we can put false at Memo ij, and then we can return false. Let's go over the time and space complexity. So the time complexity is of m times n, where mn are the length of the two input strings. This is because there is a total of m times n states because of I and j. And then for space complexity is O of m plus n plus O of m times n. So it's O of m times n. Now O of m plus n, that's the recursive call stack memory. And the other one is our cache, the Memo. Let's go over the code. So let's first validate the input parameters. So if s1.length plus s2.length is not equal to s3.length, then we can just return false. Then we're going to create our Memo, our new Boolean array. The rows indicates I, so it's s1.length plus 1. And the columns indicates j, so s2.length plus 1. And then we're going to pass in our Memo here. Now we're going to update our base cases. So if I is equal to s1.length and j is equal to s2.length, this means both of the pointers are out of bound. This means we have checked all the characters. This means we can return true. All of the characters match. If Memoij is not equal to null, this means we have already calculated the results for ij. Then we can just return the results. Now this one is if I is currently not out of bound and the current character at index I inside S1 is equal to the character inside S3 at I plus j, this means we can check if we can interleave the strings by moving I forward. So if the recursive call is true, then we want to cache the results before returning true. Same case here. As we move j forward, if the current character at j inside S2 is equal to the character at I plus j inside S3, we want to check if we can interleave the strings by moving j forward. And then if the recursive call is true, we want to cache the result too, and returning true. Else, if we have failed to interleave, we can just cache false at the current Memoij. In the next video, we'll be going over the bottom-up array, the bottom-up 2D matrix approach of interleaving strings. Let me know if you have any questions in the comment section below.